Okay, now we want to talk about naming epoxides. And so epoxides, I haven't said a word about epoxides yet, right? So we're going straight to naming them. Epoxides, where's my marker, are cyclic ethers. More specifically, they are three-membered rings. That's an epoxide right there. So for cyclic ethers, the size of the ring determines the parent name of the molecule. So this is an oxaran, this is an oxetane, this is an oxolane, and this is an oxane. And the only ones we're going to look at are these, oxarans, okay? Now, oxarans are also known as epoxides. Okay, oxarans are also known as epoxides. Now, above, which cyclic ether system do you think is most reactive? Look at all these. Let's rank these. Let's call this, I'm going to call that 3, 4, because there's a 5-membered ring, a 6-membered ring. Which is most reactive, do you think? 3, 4, 5, or 6? Which is most reactive and why? Good question. Say it out loud. Say your answer out loud. If you say, I don't know, then you need to write that down and come and ask. Okay, so now that we know that, an epoxide can have up to 4 alkyl groups, of course, right? Because you got a carbon there and a carbon here, carbon here, and a carbon here, and 2 of the bonds are there, of course, so you've got 2 more, right? So that's more. You can have alkyl groups there. How many? Well, you can have a total of 4. So the simplest epoxide has no alkyl groups, they're all hydrogens, and this is called ethylene oxide. It's called ethylene oxide because it's made from the oxidation of ethylene, right? And believe it or not, that is ethylene, okay? Really, the IUPAC name is ethene, but, well, we call it ethylene is the common name, okay? So when we oxidize that, right, it becomes ethylene oxide, all right? Now, although they're unstable, epoxides are found commonly in nature. Real interesting. So here's an epoxide. It's got 2 alkyl groups on it. There's one alkyl group, right? And there's the other alkyl group. Can you see that? And this is a pheromone for the gypsy moth. It's a sex pheromone of a female gypsy moth specifically, and you know the reputation of female gypsy moths. I don't think I need to say anything more about that. So here's another epoxide, right? Look, there's 2 epoxides in this one structure, and this is a sex pheromone of the female American cockroach. Okay, so those are some examples of epoxides that are found in nature, and there's more. Actually, you know what? I don't have any more here in this presentation, but the book's got a couple other examples that are pretty interesting. So there's 2 methods for naming epoxides. The first method is to find the longest continuous carbon chain and consider the epoxide as a substituent, right? So you have 1, 2, 3, 4, 5, and your epoxide is right here. And so you have to say 2,3 epoxy, right? Can you see that? 2,3 epoxy is the substituent. And there's also a methyl group, right? There's a methyl group, and there's an ethyl group. And the ethyl group is on the 3, and the methyl group is on the 2. And this is taped together alphabetically, and so it's simple enough. If you can see the epoxide, this is probably the more intuitive way for you, the way that's more consistent with the methods of nomenclature that you've already mastered, okay? 3-ethyl, 2-methyl, 2,3 epoxy, pentane, where the epoxy represents the oxygen ring, 3-membered ring, as a substituent, okay? Oxaran is the other way, where oxaran is used as the parent name, where this is oxaran, okay? And you get 1, 2, 3, where the oxygen gets the 1 for oxaran, okay? So if the oxygen is 1, the bigger groups are going to be on the 2 for higher priority, okay? 1, 2, and then the smaller groups are going to be on the 3 for a lower priority. All right? I think we're going to have some examples here. Okay, so name the molecules below by both methods if possible. All right? So the first method is to name the epoxy as a substituent. Okay, and where would that be? Watch this. 1, 2, 3. 3, 4, 5, 6. So it's 1, 2 epoxy cyclohexane, right? 1, 2 epoxy cyclohexane. And on the 3, you have, do you recognize this? Remember this? This was just from the beginning of this chapter, right? 3 what? 3 ethoxy. Okay, so it's 3 ethoxy, 1, 2 epoxy cyclohexane. Okay? All right, what about this one? Oh, now, can we name this as an oxyran? What's the longest continuous carbon chain? Oh no, if we name this as an oxyran, look at, that's the parent name, right? So what would that be? Well, we don't have a way of doing that. We don't have a way of naming this would be like 1, 2, and 3, right? But we don't have a way of naming a substituent that shows up on both sides, okay? That's like a bicyclic, and we have not learned how to do those. So you can only do this first one with the methods that we've learned. You can only use one method for that, and that's this one here, okay? Now here, possibly we can. So the longest continuous carbon chain, 1, 2, 3, 4, 5, 6, or, watch this, let's go with a different color. Or 1, 2, 3, 4, 5, 6. Looks like blue is going to win here, right? Because that's got the substituents in the lower end. So looks like it's 1, 2, 3, 4, 5, 6. Hexane. 3, 4 epoxy. Oh, you know what? I didn't even look to see if these were alphabetic. They're not. These are not alphabetic. So these are going to be switched. Somebody's probably already in your mind thinking, hey, wait a second, Dr. Kopic. Those are switched, and you're right. Okay? So it's 1, 2 epoxy, 3 ethoxy, right? Because it's named as a substituent. I'll switch this around in just a second if yeah, I do. I have to do it again here too, right? Because look there's my ethoxy. So it's 2 ethoxy. Oh, I didn't say if this was R. This is R or S. I didn't say. R or S. Wow, going too fast. Made a couple mistakes there. These are switched, and I didn't say if it was R or S. Which I'm not going to say. You need to say that. Is it R or S? You tell me. Okay, what about this one here? This is also going to be an R or S, right? But otherwise, I've got everything named. So this is going to be R or S, 3, 4 epoxy, 2 ethoxy, hexane. Wow, okay. But this one we can name with the other method. We can name this as an oxyran, right? I'm going to go with a different color here. Oh, I don't know. Is this getting too busy? Can you see it if I go with, will you be able to see a difference if I do blue? Let's name this as an oxyran. 1, 2, 3, right? So I can see it's going to be oxyran. That's this part. It looks like it's going to be 3, and what's this? 3 ethyl. I'll tape these together in a minute, okay? 3 ethyl, oxyran, and it's going to be, watch this. Oh, that's ugly. Ooh, man. No, that's ugly. I don't think we've learned how to name substituents off of substituents, right? We have not learned how to do that. If we did, then we would, I can tell you what it is. We're going to end up saying, let's see. Just a minute here, 2. Oh no, if this is the oxyran, it's going to be off carbon 2, right? 2, that's the carbon it's off of, right? Right there. 2 ethyl, okay? And there's going to be a substituent in parentheses here, which is ethoxy. Man, I'm sorry. Ethoxy. And we've got to name a locant for that too, okay? But we have not learned how to do that. I'm going to get rid of it right now. All right, so it looks like this is going to be the only method that you've learned to use for this molecule, okay? So I'm going to go look and see what Klein was expecting of us, but I'm pretty sure we only have one method for each of these at this stage in the game. All right.